Welcome to Modern Academic Studies, dear viewers. In today's lecture, we are taking some different kinds of problem. Question 1. Find df, that is the domain of the function fx is equal to under root x into x minus 1 into x minus 2. Okay. Solution. Obviously, we know that under root something must be greater than or equal to 0 for the function to be defined. Okay. So from here, find the critical values of x on the number line. See here, if I put x is equal to 0, then everything 0 equal to 0. Okay. Then 0 is a point acceptable. And then x is equal to 1. And then 2 also a point of the domain under this condition. Now you see that the number line divided into 1, 2, 3, 4 parts. In such a case, we have to justify each of the regions with respect to these quantities. So for example, minus 1. So you see that minus 1 and here also minus 2 and minus 3. Again it is less than 0. That means any number we do not like that. Okay. It is not true for that. So come in between 0 to 1. So you take something half. Then what happens? Half positive, half minus 1 negative, half minus 2 negative, negative, positive. Again it is acceptable. Giving some positive values means greater than 0. When you come to this 1 and half, so what you will get? 1 and half positive, 1 and half minus 1, it is also half positive, positive, and here 1 and half minus, it is remaining minus. So again it is less than 0. And you come to this interval again, take plus 3, then 3 positive, 3 minus 1 remaining plus 2 positive, and here 3 minus 2 equal to plus 1. So all giving something positive greater than 0. So plus. Okay. So this shows that we are having this interval and this interval. Okay. And here also it is not possible. Okay. So domain is equal to see 0 is included 0 to 1. Union of 2 to infinity. Okay. So this is the answer. Next we are taking another problem of square root type. And find the df and rf of the function f(x) is equal to root over 9 minus x square. I am taking this one, and next I will take reciprocal of this. Okay. So solution, fx is equal to root over minus 9x square. For fx to be defined, 9 minus x square must be equal to or greater than 0. X square minus less than or equal to 0. Okay. By changing the sign, x plus 3 into x minus 3 less than or equal to 0. Find the values of x for which the quantity becomes 0. So x is equal to minus 3, so whole quantity will be 0. So dark point you can give here, minus 3, again plus 3, minus 3 equal to 0 into this equal to 0, plus 3. Now we see that the number line is divided into 3 parts. Take minus 4, then minus 4 plus 3 here remaining minus, and here also minus. So minus plus something greater than 0, which is not true with respect to this. Now take something in between that. Take 0 plus 3 equal to 3 into 0 minus 3. So minus 3 into 3 equal to minus 9 less than 0. And then take something greater than 3, suppose 5. Then 5 plus 3 plus 8. 5 minus 3 equal to plus 2. So 2 into 8 is equal to plus 16. We are getting some values greater than 0, but here we should get less than 0. So we understand that this and that interval not valid. Okay. So this is only up to here. Domain is equal to minus 3 to plus 3 closed interval. Okay. This is the answer. Now about the range. Now root over y minus x square equal to y we can write, because fx equal to y. So by squaring, 9 minus x square is equal to y square. 9 minus y square is equal to x square. But x square equal to or greater than 0. So we can replace this equivalent quantity of x square with that inequality condition, 9 minus y square greater than or equal to 0. Okay, or we can write y square minus 9 will be less than or equal to 0 by changing the sign, because we need to find y. It is easy for us. So factorize now. Y plus 3 into y minus 3 less than or equal to 0. Draw a small number line. Now you see that equal to 0 means at y is equal to minus 3 and at y is equal to plus 3, whole quantity becomes 0. So we are getting two values, minus 3 and plus 3. Take something in between. Take 0, y 0, so plus 3, and here 0, minus 3, minus plus minus 9, which is less than 0, it is 2. Now justify this region. Take minus 4, which is greater than 0. Similarly, here you justify plus 5, then 5 plus 3 plus 8, and here 5 minus 3 equal to 2, so 2 into 8 plus 16 means plus 16 is greater than 0. This shows that y belongs to minus 3 to plus 3. With respect to this, we have got this interval, and whereas that condition of the function is showing that it can be from 0 to infinity. So the intersection of these two, from 0 to infinity and from 0 to 3, is this one is the acceptable thing, okay, common domain. So range of the function is equal to from 0 to 3. Okay, that is the answer. Now we shall take the reciprocal of this function. Find the domain and range of the function f(x) equal to 1 by under root 9 minus x square. For f(x) to be defined, we must have this. You already know that if it is 0, then 1 by 0 undefined, when fx becomes undefined. So we cannot make equal to 0 but greater than 0. Then total things will be coming again positive. Okay. So with that condition we start again. Again we see that minus x square is there. So by changing the signs, x square minus 9 will be less than 0. Factorize this. Draw a number line. Find the critical values. Obviously x is equal to minus 3 is a critical value which makes it 0. X equal to plus 3 makes again 0. But do not give dark points either to the right or left of these critical values. Some range will be acceptable by taking any value between these two critical values. By taking 0, so 0 plus 3, here 3 and here minus 3. Plus 3 into minus 3 equal to minus 9, which is less than 0. We have got acceptable values. And take something here positive, plus 5, say plus 5 minus 3 plus 2, and here plus 8, so plus 16 greater than 0, so plus sign we are giving. Here take again minus 5, so plus 60, it is also plus, okay, greater than 0. So we have seen that any values within this open interval are acceptable. Okay, df is equal to minus 3 to 3. This is the answer. Okay, now we are going to find the range. Again, y is equal to 1 by root over 9 minus x square implies y square is equal to 1 by 9 minus x square. Cross multiplying 9y square minus x square, y square is equal to 1. 9y square minus 1 is equal to x square y square. 9y square minus 1 by y square is equal to x square. But x square cannot be negative. 9y square minus 1y y square greater than or equal to 0. See, y square cannot be 0, otherwise total quantity will be undefined. Okay, so then it implies that 9y square minus 1 should be greater than or equal to 0. 9y square minus 1 greater than or equal to 0. Again factorize. 3y plus 1 into 3y minus 1 greater than or equal to 0, or y plus 1 by 3 into y minus 1 by 3 greater than or equal to 0. So same way, find the critical values here minus 1 by 3 and here plus 1 by 3. Okay, these are two acceptable values here, but we do not know still now whether this region or that region or this region are acceptable. In between you take something 0, then plus 1 by 3, and here minus 1, 0 minus 1 by 3, plus minus minus, something which is negative. Okay, it is not satisfying that relation. Now come to this side. Suppose minus 1 is less than minus 1 by 3. So minus 1 plus 1 by 3, something minus remaining. And here minus 1 minus 1 minus 1 by 3, again minus 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 plus greater than 0. And here again I am taking plus 1. So plus 1 plus 1 by 3 plus, and plus 1 minus 1 by 3, again something plus. Okay, so plus plus something product greater than 0. So again this, and this is showing that one value starts from here up to infinity, and here again another value comes here minus infinity. Okay, this shows that y belongs to minus infinity to minus 1 by 3 union plus 1 by 3 to plus infinity. Okay, but you see that this under root function is never possible negative, so but y is not equal to negative, therefore range means y belongs to this interval only. Okay, that means the range is equal to 1 by 3 to infinity. Okay, now let us take one more problem. Find the domain and range of fx equal to modulus of x minus 4 by x minus 4. Okay, so fx is equal to mod x minus 4 by x minus 4. Clearly, df is equal to r minus 4. This is the domain. Again, fx is equal to, see that if anything positive greater than 4, suppose it is 5, then inside mode 5 minus 4 equal to plus 1. Here also 5 minus 4 equal to plus 1. So 1 by 1 is equal to 1. Okay. For all x greater than this, we see that the things will be 1. Okay. For x greater than 4. Okay. And again you see that if x values are less than 4, suppose this is x is equal to 1, then 1 minus 4 equal to minus 3 equal to plus 3, and here again 1 minus 4 equal to minus 3, so plus 3 by minus 3 equal to minus 1, and like that it is for all x values, it will be minus 1. So for x less than 4, okay, it is very easily observable, hence the range is equal to 1 and minus 1, or minus 1 and 1. One more problems on this function. Draw the graph of fx equal to x minus 4 by x minus 4. Okay, so solution fx is equal to mod x minus 4 by x minus 4. Clearly, fx is equal to plus 1 for all x greater than 4 and minus 1 for all x less than 4. And obviously at x equal to 4, the function is undefined. Okay, 1, 2, 3, 4. Okay, so at 4 undefined, but just greater than 4, it is 1. Okay, so the graph starts at 1 unit. So this is the graph showing two small void circles. Okay, that means it is not exactly reaching to 4 either from right or from left. Okay, so this much is for today's session. Okay, next day we shall take some more problems of some other categories. Thanks for watching.